Welcome back, 5th grade. I hope you are having an amazing week and that you are working hard and doing well on your math. I brought a button home with us that we haven't seen for a while.
That was easy.
And I hope that you're feeling that way about your math. I know that what we're doing with fractions is really just accumulating. We started with equivalent fractions, and then we started adding and subtracting fractions with unlike denominators. And this week, we're just going to take one step further with that. I'm not going as far as Mrs. Comstock is going and Mrs. Spink is going with her class. We're not going to subtract with mixed numbers, but we are going to add with mixed numbers. So again, like I said in last week's video, if you're still having problems with any of those other two fraction concepts, you need to pause and you need to get a hold of me right away so that we can go over some of those concepts. I can do some Zoom meetings with you. I can give you some extra practice. I can do lots of different things, even remotely, to make that a little bit easier for you. So you've got my email, you've got my phone number. Again, don't struggle through this alone because this week is just one step further. So if you're not finding the math like this, I expect to hear from you, please. This week, just like always, I'm expecting while I'm doing this video lesson that you are following along and that you are doing the examples with me. So you're going to need some paper, you need a pencil, and you need your multiplication chart. Also, if you have access to this video off the slides, there should be a template on the slide after this video. It might help you out just a little bit if you have taken a look at that. If not, don't worry about it. It's going to be on the video here as well. So I'll see you back in just a little bit if you need to, and we'll get going together. All right. So a review from last week, please. We were finding, actually 2 weeks ago, we were finding equivalent fractions that are equal to each other. So I'm going to start with a simple one here. Let's say I've got 2/5, and I want to find something that is equal to that has a numerator. Let's go with the denominator. A denominator of 10. And so I've got to figure out what my numerator is going to be. So I bring down my denominator, the 5, and I'm going to skip count out with that. So 5, and then 10. There's my new denominator. So 5 times what is 10? Times 1 times 2. So my form of 1 goes up here. 2 over 2 is my form of 1. 2 times 2 equals 4. So 4 over 10 is equal to 2/5.
That was easy.
I'm hoping you're finding that easy. If not, again, you should be calling me or emailing me. Okay. This was last week's assignment. All right. We had the fraction 2/5 plus 1/3. So I'm going to rewrite my fractions down here on the template. Oh, I've got 1/3. And then 2, oh my goodness, computer problems already. Plus 2/5. I need to take these two denominators, the 5 and the 3, and I need to bring them down here. And I need to find out what my new denominator is going to be, what they have in common. So skip counting out by 5s. Again, you're doing this as well. Maybe I'm going too slow for you. So I've got 5, 10, 15, 20. I'll stop there just because I'm kind of running out of room with the template. 3, 6, 9, 12. 3, 6, 9, 12. I'm going to pause there, see if I've got one in common. I do not. I've got one more line though. 3, 6, 9, 12, 12, 13, 14, 15 would be my next one. And yes, I have one in common. So it looks like 15 is my least common denominator, the first one they have in common. So 15 is going to be my new denominator. Sounding familiar again? Hoping so. All right, so I'm asking myself 5 times what gives me 15? You can always use your multiplication chart, right? Or I've got it here, times 1, times 2, times 3. So 3 goes here. 3 times 2 is 6. 3 times what gives you 5? Again, you can use your multiplication chart, or I've got it right here. Times 1, times 2, times 3, times 4, times 5. 5 over here as well, because this gives 5 pieces out of 5 is 1 whole. 1 times 5 is 5. I'm going to look back up here and remember that I'm adding still. And I'm adding just my numerators, my top numbers. So 6 plus 5, 6, 7, 8, 9, 10, 11. So my answer is 11 over, you got it, good job, 15. Bottom number stays the same. And then I'm going to ask myself, is that proper or improper? Is it less than 1 whole? Good job. It is less. It is proper. So
That was easy.
if you're good with this, you're good for this week's lesson. If not, I can't keep saying it enough. You need to contact me. You need to be responsible for your own learning. We're not across the table from each other, so I don't know what you're stuck on. You need to reach out and let me know. This week's, all we're doing is adding the whole numbers right here. Look, the fraction piece looks the same. Just like over here, fractions that don't have the same bottom number. All we can do to make it any more complicated is add a whole number. That's it, you guys. Not real complicated. Now, the way I'm going to show you just might look a little funny, but that's, again, just because I can't sit across the table from you. So here's what our template looks like. This line here is to separate our whole numbers from the fractions. So I've got 8 and 3/6 plus 1 and 2/8. My whole number is going to go here. 8, and then my fraction 3/6 is going to go here. I'm just going to build that from over here. I've got 3/6. So I've got 8 and 3/6 plus my whole number 1 and my fraction 2/8. So I've got them completely separated, my whole number from my fraction. Now, I can do this a couple different ways. I can go ahead and add my whole numbers if I want, because they're whole numbers. Or I can wait and solve everything at once later. I think I'll wait, because here's my problem with my problem. My denominators here, the 6 and the 8, are not the same. They're not the same piece sizes. So just like we've been practicing before, I cannot add them or subtract until they're the same size. So guess what? Just like last week, we got to come down here and find the new equivalent fraction denominator. So I'm going to bring down the 6, and I'm going to bring down that 8. Using your multiplication chart, you're going to skip count across. So you've got 6, 12. You're probably writing faster than Mrs. Spitzley can draw. 6, 12, 18, 24. I do not like my 6s. You're probably faster than me. And 30. Okay. Then I need to do my 8s. Again, use your multiplication chart. You've got 8. 8 times 2 is 16. Oh, come on. 16. 8 times 3 is 24. I hope you're telling me to stop, because there we have it in common. 24. Can you see it? 24 and 24. All right. Now, before, I gave you this nice little template here to find your equivalent fractions. It gets a little messy when you're working here, so I didn't give you quite as much fill in the blank, because, hey, this is our 3rd week doing this, so I expect you to kind of be able to do a little bit more. So here's what that's going to look like. 3/6, what do we need to multiply by to get to 24? Here we go. Moving it to 24. So 6 times what gets you 24? Times 1, times 2, times 3, times 4. We're going to multiply it by 4. Now, remember this is a fraction, So what needs to go up here? Because this still needs to be a form of 1. So yep, you're going to put a 4 up here. So then I've got 3 times 4 is 12. So now this is my new denominator. Now, if you need to, you can come up here and you can write the multiplication sign in here, and you can write the equal sign in here as well. Whatever you need to make it less confusing, right? Now I need to find my equivalent fraction for 2/8. Remember, I'm going to move that to denominator of 24. My piece sizes need to be the same. So I'm asking myself, 8 times what gave me 24? Times 1, times 2, times 3. Remember what we've been doing. Third week on this. This needs to be a form of 1. So this is going to be 3 over 3. Because if I had 3 pieces and I ate all 3, I ate the whole thing. Now we're multiplying here. 2 times 3 is 6. And again, it's just not easy for me electronically, right? I can multiply here, and I'm equaling here. Now take a look. This is what we're looking at. Those are my new equivalent fractions. The piece sizes are the same, so I can now just simply add my numerators. I've got 12. Yeah, it didn't work out real well. I've got 12, and I've got 6. Now, sometimes you guys need to rewrite that over here, whatever you need to do to make that work for you. But I've got 12 plus 6, 12, 13, 14, 15, 16, 17, 18. So your answer is 18. 18 over 24. Again, I bet you can write this so much faster than Mrs. Spitzley. Right? And then you're also going to add your whole numbers over here. 8 plus 1 more is 9. And I just need to make this not look like a fraction number. So I'm going to enlarge it a little bit. Okay? So you've got 9 wholes and 18 over 24. Ask yourself about the fraction. Is that a proper or improper? And it is proper. It's less than 1 whole. And so you're all done with that. I don't think we can hit this yet, but let's do another one together. We've got 7.5 plus 1 and 5/10. We're going to bring this whole number down. Remember, this line separates our whole numbers. So we've got 7 plus 1. And then we're just going to simply take the fraction 1/2. And our fraction 5/10 down. Looks like I could have given myself a little bit more space, huh? All right. Are my piece sizes the same? No, they do not have the same denominator. So I've got to find an equivalent fraction. I'm going to bring down my denominators of 2 and 10 to find a new denominator. I can do that from here. I can do it from over there. Okay. You should be doing this at home as well. Skip counting by 2s. I've got 2, 4, 6, 8, 10. And you've probably already saying that and you're going, Mrs. Spitzley, I already know the answer. And I'm actually going to stop there because you're already screaming at me, right? And you're saying, this is so easy. You're right. This one is. I put it in there on purpose. Your new common denominator is going to be 10. So coming up here then, your new equivalent fraction, your new denominator is going to be 10. So I'm going to go ahead and put both those in there. This is feeling a little bit easier, like you kind of got this. So you're asking yourself, 2 times what gives you 10? Times 1, times 2, 3, 4, 5. It's times 5. Again, if it helps you, write that in there. It's just not there in the format from last week. Okay. Now this has to be a form of 1. So what goes up here? 5. And then you're multiplying. 1 times 5 is 5. There's your equivalent fraction. 1/2 is the same as 5/10. And look, this didn't change, did it? Or maybe you're still stuck on that, so let's talk it through. 1 times what gives you 10? 1. This needs to be a form of 1. So it goes up here, 1. Again, let's write in here that you're multiplying. In your multiplication, write in your equal sign. 1 times 5 equals 5. Okay? So now here is what you're now going to be working with your addition part, because these did not have the same denominator. This is what you're going to be using from here on out. You're going to use the numerators. 5 plus 5 equals 5. Did you get your answer? I did too. So you've got 10. Your denominator stays the same, so it would also be 10. And I can come over here and I can add my whole numbers. 7 plus 1 is 8. Don't write it small. It needs to be a whole number. It needs to be larger, because otherwise it's going to look like 810 and it's going to look like 810. So I've got 8 and 10/10. Now, you can stop there and it will be fine, but I'd like to challenge you to look at this fraction 10 over 10 and realize that that is also equal to 1 whole. So if you'd like to take it one step further, you can say, hey, yeah, let's not do it that way. You can also say that this is also equal to 1 whole. Remember doing this before? And that 1 whole, add your whole numbers together, 1 plus 8 equals 9. And that 9 would be your final answer. Either one is fine. Are we getting close to hitting the easy button? I've got several more examples. Let's try at least one more, maybe 2. Here's your next problem. 1 and 1/6 plus 1 and 1/9. Whole numbers go over here. So I've got 1 and 1/6. Ooh, I wanted to go. Plus 1 and 1/9. Okay. Are the denominators the same? No. So, we're going to have to find equivalent fractions. But you're pretty glad I haven't broken into song yet. So I'm going to bring down the denominators of 6 and 9 and skip count those out. So 6, 12, 18. See, after 18 is 24, and then 30. Are you able to do this faster than me at home writing? Sometimes it is not easy to click and drag. 9s, you've got 9. 9 times 2 is 18. 18 times 3, following it on your chart, is 27. What, did you tell me to stop? Good. Yeah, I see one in common now too. Good job. Yeah, it's got 18. That's going to be your denominator of your equivalent fractions. Nice job. All right, so let's come up here then. 18 will be your new denominator. So then you're just finding the equivalent fractions. All right, so I'm going to set my no, I'm not. I'm going to set my problem up, and then I want you to do the same. Maybe I'll get it set up. Come on. Here we go. All right, I want you to have your paper to look like this. No cheating. And then I want you to pause the video, and I want you to find the new equivalent fraction. Show me your work here, what your form of 1 is going to be, and then find your new numerator. And then can you go all the way through and find the addition of your whole number and your fraction? And then come back here and I will show you the work. You can always hit play when you get stuck. All right? See you back in a couple minutes. Hey, good job working until you got stuck. Let's check your work. All right, 6 times what give you 18? It was 3. So your form of 1 over here is going to be 3. Are you still writing the times in there and the equals? It's all right if you are, and it's all right if you're not needing it. So moving across the top, 1 times 3 equaled 3. So your equivalent fraction is 3/18. 1 times 9 times what gave you 18? It is 2. Your form of 1 is 2 over 2. Again, if you still need to write that symbol in there, that's fine. You give your eyeballs what they need for your brain to see it. So then you're multiplying across, and you've got 1 times 2. So you've got 2/18. And then this is what you're adding. Are you still circling? Again, give your eyeballs what it needs. This is what we were doing in school before you left. 3 plus 2 is 4. So you've got 5 over 18. Which is a proper fraction, less than 1. Adding your whole numbers, you've got 2. And you should write that larger. So it should be like that. Did you get 2 and 5/18? If so, good job.
That was easy.
Let's do one more problem together and see how you're doing. We've got 3 and 5/7 and 2 and 5/9. Whole numbers and the fractions. Get your paper set up. Sometimes I feel like I'm watching paint dry when I move these around. All right, are the piece sizes the same? No. So you know to bring those denominators down, and I want you to work through this problem until you get stuck, right? Can you find the common denominator? Can you bring that up here? Find your equivalent fractions. Can you add it up and add up your whole numbers? I will see you back here in just a minute, or when you get stuck, work as hard as you can. See you back in a couple minutes. Hey, welcome back. How far did you get stuck? How far did you get until you get stuck? Let's take a look here, all right? I hope you got very, very far. I'm not going to write out all of the common multiples because you know what? You had your multiplication chart to do that. I think as you wrote them out, though, you probably found that there were not enough lines down here and that you had to keep going with them. This was a pretty long, hard one. When you ended up with those, you should have found that your common denominator, your very least one, was actually 63, which is a pretty large one to have. So 63 was your least common multiple, your new denominator. So if you second guessed yourself, you shouldn't have. So then 7 times what gave you 63? The answer to that was 9. All right, so 9 over 9. Again, if you need to write this in here, you know what to do. So then you're saying 5 times 9 across the top. 5 times 9 is 45. 9 times what is 63? And the answer to that is 7. So then you might be going, you just multiplied the two of those together. Sometimes that works. Okay. So then I'm going to write in there for you the multiplication and the equal sign. And then you're multiplying across the top. 7 times 5 is 35. All right. Good job. Did you remember that these are the problems that you're working with? Okay. And you need to add up the numerators, so your top numbers. Now, some kids like this, these are big, and you can't just use your fingers and calculate on. If you did, God bless you, because counting on 35, that is a whole lot to do. So I'm actually going to come over here, and I'm going to write myself the problem and do some carrying if I need to, because that's a pretty big number, more than I can use my head or my fingers for. Caught my 4th grade son trying to do these in his head the other day, and he got them right, but whew, that's a lot of work. All right, so I'm going to look at it this way. 5 plus 5. 5, 6, get it? 10. Carry. And then I've got 4 plus 3 plus 1 more is 8. So that's actually 80. Okay? So your answer for the fraction side is 80 over 63. And adding up your whole numbers, 5 plus 2, 3 plus 2, you should have gotten 5, making that larger than your fraction number. Okay? If you got that, great job.
That was easy.
Good job. You're getting much, much better at that. If you're looking at that and going, Mrs. Spitzley, there's a more correct answer, you're right about that too. Because if you're taking a look, hold on just a minute. If you're taking a look at this answer, you could tell me that, Mrs. Spitzley, this numerator is larger than the denominator. And you're right. We talked about that a lot before we left. And so a more correct answer would have been to be able to say, hey, how many pieces would it take to make one whole? And it would have been 63 pieces out of 63. And I don't think there's enough to make another whole. So I'm just going to count up 63, 64, 65, 66, 67, 68, 69, 70. And then to go from 70 to 80 would be another 10. So 10 plus 7. There would be 17 pieces left. And the piece size is 63. I'm going to circle this because it is equal to 1 whole. So this 1 whole plus this would give you how much? 6. Give you 6. And then your leftover pieces is 17 over 63. Right? So there, you've got 2 different correct answers there. You could have given me this answer right here. That would be an okay answer. And this would also be an okay answer. 2 different correct answers that I will take from you this week. All right? So I want you to work hard with your assignments. Also, don't forget your daily math review sheet because those are going to keep you sharp on the skills that you need for 6th grade next year. Work hard on your fraction assignments. Please, please, please reach out for me. Reach out to me if you're having trouble and you need some work. Work hard. Work until you're proud and know that Mrs. Spitzley loves you very much. Have an amazing week, and I'll see you next week.